Alright, in this video, we have a very short summary. I just compare the one that comparison between the scalar product and vector product. Okay, the purpose here is to summarize the important properties of scalar product and vector product that you should know, right? There are many scalar product, many properties and vector product. So, but in this video specifically, I just target some properties that you must remember. So, as you know that dot product is defined to be A dot B equals to magnitude of A, magnitude of B, cosine theta, right? And this is for scalar product, right? Now this is for scalar product, and for cross product, it will be A cross B is defined to be magnitude of A, magnitude of B, sine theta, and the unit vector in the direction of A cross B, right? So these two definitions will bring you different the difference in the properties here. So as you know that a dot product will produce a scalar, right? A scalar, and a cross product will produce a vector C, right? Another vector. So this is the first difference. So you have to know that this is a scalar quantity and this is a vector quantity here. So, and right, the most obvious difference is, let's say if you have A dot A, it will produce a magnitude of A square here. As in this video, I just compare. I'm not going to tell you why you're getting this. You have to watch the video that I'm talking about how to derive this, right? So the comparison is that if A dot A is a magnitude of A square, you must write the magnitude here. So, and the second will be the cross product. If two identical vector, when you cross, you will get a zero vector. This is also proven in the previous video. So, and these two is different. Once A dot A will produce magnitude of A square and A cross A will produce a zero vector. This is a very important properties that you must know before you answer your exam question. So, secondly, so A dot B is the same as B dot A, right? They produce the same number, the same scalar. So they are commutative. And the second property here, I try to compare this with another property here will be A cross B. Is A cross B same as the B cross A? So the answer is no, because A cross B and B cross A, they have opposite direction, even though they have the same magnitude. All right. Okay. So the third comparison is, let's say if A is perpendicular to B, vector A is perpendicular to vector B, the result will produce that if you use scalar product, the vector A, vector B, if you do dot product, you will get a zero. The scalar will be zero. And whereas for cross product is helpful in helping us to verify two vectors are parallel. For scalar product, we're usually using dot product to prove that the two vectors are perpendicular. Alright, are perpendicular. So it's a lot easier. That's why we suggest this. Even though the scalar product can use to prove that the two parallel vector, either they are parallel vector in the same direction or opposite direction. It also can using that, but it's a bit troublesome, right? So for this one, if A is parallel to B, then this is also very easy if you want to prove two parallel by using cross product. Because why? When two vectors are parallel, if you're using cross product, you cross the two vectors, you are getting a zero vector. This is very special. Any two vectors that are parallel, you are getting a zero vector. So this is the first three comparisons that you must know. Okay, I tell you, I promise you, these three you must know before others properties, and you must able to compare between these two. And one more thing I want to remind you that this formula can be rewrite in a useful form. A useful form means that a form that I magnitude everything here, magnitude A and magnitude B, sine theta. So if the magnitude of a unit vector is 1, right? This one you can use to find the angles. The similarity between this formula and this formula is they can using to find the angle between the two vectors. Right, the angle between the two vectors. But I will tell you that for all the vectors that I teach in my lesson, angle between line and line, plane and plane, line and plane, everything we were using dot product because it's a lot faster compared to this, right? Okay, so I hope you understand. This is the short summary and the important property that I think you should know, right? Okay, that's all for this video.